Now next is recording rain gauges. So the first one under recording rain gauge is tipping or tilting bucket type rain gauges. Now the principle of this tilting or tipping bucket is actually very simple. There is a container, you can see a container here. This is divided vertically into two compartments. You can see one compartment here and here, and this is balanced in an unstable equilibrium about the horizontal axis. So in its normal position, it rests against one of the two stoppers. One stopper is here and the other stopper is here. It prevents it from tipping over completely, okay, completely to both sides. So it can tilt on both sides. So when the rain falls, it is led from a conventional collecting funnel into the uppermost compartment. Now the uppermost compartment is here. So the capacity of each compartment is about 0.25 mm. So once this compartment completely fills with water, it becomes unstable, and its present position changes when it tips to the other side. Okay, so when it tips to this side, what happens? This compartment, the first compartment, comes into position. Again that fills. After, when it fills, it again tilts to the left side. Okay, so what happens when each compartment tilts? The water contained in each compartment will get emptied into this measuring jar, and then each time one compartment will keep on changing its position. So the compartments of the container are so shaped that water can flow out of the lower one, and it leaves it empty. Now this continuous movement of these buckets actually helps to record the measurement of rainfall. One of the main disadvantage of this type of rain gauge is nothing but, as I said earlier, the compartment is designed in such a way that it could carry only a volume of 0.25 mm of rainfall. So when the rainfall is very heavy or the intensity is heavy, what happens? The in higher intensities, the bucket actually tips very rapidly. So that is one of the disadvantages. So in lower intensity rainfall, it will take very long time to tilt. And the biggest advantage of this tipping bucket gauge is that this is the only recording rain gauge which can be used in remote places by installing the recorder at a convenient and easily accessible location. So that is one of the main advantage of this type of rain gauge. Now you can see a picture here. So two buckets can be seen here. So this is a figure of tipping or tilting bucket. Okay. Now moving on to the next type, weighing type rain gauges. So in this type of gauge, the rain falling into this receiving area is collected by the funnel and is led to the storage bucket, which rests on a weighing platform. So the weight of the rainfall received is recorded continuously by transmitting the movement of the platform through a system of links and levers, and it is actually connected to a pen, you can see here, which actually makes a trace, okay, in this graduated chart. And this graduated chart is adjusted around a drum, a clock driven drum with a chart. So the drum is driven mechanically by a spring clock. Okay, I'll show you a figure of this clock driven drum with chart. See, this is the mechanism. Okay, so when the rain falls, it completely fills the bucket, and due to the spring mechanism, the bucket moves up and down. So the pen records the reading in this chart. Okay, now there is one disadvantage for this type of rain gauges. That is nothing but this type of gauge normally has no provision to empty itself. That is, when this bucket is full, it cannot tilt to any one side and empty it. But one has to come and again take out the water from this bucket and keep again. Okay, so that is one of the disadvantage. And main advantage is that it can record even snow, hail, and mixture of rain and snow. Okay, so that is one of the advantage. Now this is a weighing type rain gauge. Now the third one is float type rain gauges. Okay, so this type of rain gauge is also known as siphon type rain gauge. The name is because it uses the siphon mechanism in order to empty the rainwater collected in the float chamber. Okay, siphon mechanism is nothing but the mechanism by which the liquid flows by gravity. Now let me explain this. So when the rainwater entering the gauge at the top is led into the float chamber is here, through a funnel and a filter. So the purpose of this filter is to prevent dust and other particles from entering the float chamber. So it can hinder the siphon mechanism. Okay, so the float chamber, it consists of a float. This is the float with a vertical stem protruding outside. Okay, to the top of which a pen is mounted. So top you can see a pen attached to this chart, and down there is also a small protruding part. Now the pen actually rests on this chart, secured around a clock driven drum, as we saw earlier. So there is a small you can see the thing here also. Okay, the chart. Now there is a very small opening, not opening, a small compartment by the side of this float chamber, which is actually connected to this float chamber through a small opening at the bottom. So this is called the siphon chamber, which has a small vertical pipe with the bottom end open, and the top end is almost touching the top of the chamber. So during the storm, the rainwater collected in this float chamber, it rises the water surface, and along with the water, the float also rises. Okay, this float also rises. So this actually enables the pen to make a trace of cumulative depth of rainfall on this chart. So the when the float chamber is completely filled with water, it then reaches the top of the chart. So at this instant, the siphoning occurs. So the full water will be automatically going out from the chamber outside. Okay, through this siphon chamber. Now, so the float chamber is emptied and the pen is again brought to zero of the chart. As the rain continues, what happens? The pen rises again from zero of the chart to the top graduations. Okay, so this is the whole mechanism of float type rain gauges. So that is about the type of rain gauges. You can see a symbol type of float type rain gauges here. So that's it